Cloudbursts happen all over the world. But nowhere do they seem to become as devastating as they do in the Himalayas. Why? Is it simply because these mountains are higher? Or have the Himalayas become the perfect natural trap, turning ordinary storms into extraordinary disasters? In this video, we'll uncover the science behind one of Earth's most dangerous weather phenomena. You're watching Earth Diary. When people hear the word cloudburst, they often imagine a cloud suddenly bursting open, like a giant balloon filled with water. It sounds logical. But it's wrong. Clouds don't burst. The name survives from an old belief that clouds stored water like floating containers. Modern meteorology tells a different story. A cloudburst is an extremely intense burst of rainfall, produced when enormous amounts of moisture are released over a very small area in a very short time. Meteorologists, including the India Meteorological Department and the World Meteorological Organization, generally define it as rainfall occurring at a rate of 100 mm or more per hour over a small geographical area, typically 20 to 30 square kilometers. Imagine an entire month's rainfall, compressed into less than an hour. The ground can't absorb it. Within minutes, streams become torrents. And those torrents become flash floods, carrying mud, rocks, and entire trees downhill. That's why cloudbursts are among the most destructive forms of extreme rainfall. But here's the mystery. Cloudbursts happen around the world. So why are they especially deadly in the Himalayas? Most people assume the answer is simple. The Himalayas receive more rain. But that's not actually true. Some of history's most remarkable cloudbursts happened far from the Himalayas. In 2000, South Africa recorded more than 66 mm of rain in just 5 minutes. Missouri, USA received over 300 mm in 42 minutes in 1947. While in 1952, La Réunion Island recorded nearly 1.9 meters of rain in 24 hours during a tropical cyclone. So extraordinary rainfall isn't unique to the Himalayas. Which raises an even bigger question. Why do these mountains produce some of the world's most devastating cloudburst disasters? The answer isn't the storm. It's what the mountains do to it. But, how can a mountain change a storm? Every summer, warm, moisture-rich monsoon winds travel north, from the Arabian Sea and the Bay of Bengal. Then they meet one of Earth's greatest mountain barriers. The Himalayas. The air can't move through the mountains. So, it climbs. As it rises, it cools. Water vapor condenses. Clouds rapidly grow. Rainfall intensifies. This is known as the orographic effect. Mountain ranges around the world experience it. But the Himalayas amplify it. Their immense height and steep slopes force moist air upward rapidly, producing intense rainfall over remarkably small areas. But that's only part of the story. Sometimes the mountains do something even more dangerous. They slow the storm itself. Moist air becomes concentrated within narrow valleys. Storms can remain nearly stationary over one location, releasing enormous amounts of rain instead of moving on. This is called the topographic funnel effect. It concentrates moisture over a small area, dramatically increasing rainfall intensity, and making cloudbursts far more dangerous. And now the terrain takes over. The Himalayas are steep. Extremely steep. Steep slopes leave little time for water to soak into the ground. Instead, it rushes downhill. Narrow valleys concentrate the flow. The water accelerates, gathering rocks, mud, and trees, until a brief downpour becomes a destructive wall of debris. This is why a Himalayan cloudburst rarely remains just rain. The devastating consequences of this process were seen in 2010, when a cloudburst struck Leh in Ladakh. Within minutes, a torrent of water and debris swept through the region, killing more than 200 people. But even this isn't always enough to produce the most extreme cloudbursts. Sometimes another ingredient arrives. Western disturbances. These weather systems carry cold air into the Himalayas. When that cold air meets warm, moisture-rich monsoon winds, the atmosphere becomes highly unstable. Air rises even faster. Clouds develop rapidly. And intense rainfall can be concentrated over an extremely small area. The devastating 2013 Kedarnath disaster occurred under this type of complex weather setup, where monsoon moisture and disturbed atmospheric conditions combined to produce extreme rainfall, leading to devastating floods and landslides. Unfortunately, the atmosphere itself is changing. A warmer atmosphere can hold more moisture. According to the Clausius-Clapeyron relationship, every 1 degree Celsius increase in temperature allows the air to hold about 7% more water vapor. That means more fuel for intense storms. Recent studies have also found an increase in extreme rainfall events across parts of the Himalayas, suggesting that these disasters may become even more severe in a warming climate. At the beginning of this video, we asked a simple question. Why are cloudbursts so deadly in the Himalayas? Now we know. The cloudburst is only the trigger. The mountains amplify the disaster. They force moist air to rise. They concentrate rainfall. And they turn minutes of rain into catastrophic destruction. This is the mountain trap. And understanding how it works is the first step toward reducing its impact. If you enjoyed this video, consider subscribing to Earth Diary for more science-based explorations of our changing planet. Thanks for watching.